Today we're going to start chapter 3, which kind of is a tale of two stories. First, we're going to look at conditional statements and all their variations, and then we'll look at parallel lines and transversals. So on the first part, it's all about, and really this whole chapter is all about logic. Then we get to parallel lines. Can we think logically? Can we make a logical statement? Okay, so with that being said, we're going to look at inductive reasoning today to find patterns and then make and disprove conjectures. So y'all have been finding patterns for a while now. I mean, I think you even did it in elementary school. But if we think about this, let's see if we can find the next item in each pattern. So we start at Monday, then we go to Wednesday, then Friday. Looks like we're skipping every other day. So what would be the next day? Sunday. Okay, B. Looks like we go from 3, 6, 9, 12, 15. Looks like each time we're adding 3. If you pick any of these, we're adding 3 to get to the next one. So 15 plus 3 is 18. Now, if we look at this triangle, let's focus on this top point. Where does that top point move each time? So it goes to the left, then to the bottom. So now it needs to be on the side. Top, left, bottom, side. We're just rotating this triangle around. Then we look at the arrow. It starts out pointing, like if think of directions. Starts out pointing west, then goes northwest, then north. So our next turn should be northeast. Okay, so as a statement that you believe to be true based on inductive reasoning is called a conjecture. So what is inductive reasoning? Well, that's like basically saying you're trying to disprove it, and you cannot think of anything to disprove it, so it's got to be true. Let's look at A. So they have to try to fill these in. The product of an even number and an odd number is blank. Well, let's see what happens, and it gives us this hint. Remember, if the various types of numbers aren't specified, we need to try all kinds. In this case, they talk about even and odd, but what they don't mention is positive or negative. So let's just go through and pick some numbers, both positive and negative, to see if this holds. So first, I'll try positive. So even and odd number. Let's do 3 times 8. Well, 3 times 8 is 24. Okay, what about -2? That's an even number, times -7. Going to give us 14. So I've done both positives, both negatives. Now let's do 2 negatives. Oh wait, I've done 2 negatives, sorry. Let's do 1 positive, 1 negative. So how about -2 times 3? It's going to give me -6. What do we notice about all of these numbers? If you multiply an even number and an odd number, your answer will be what? Even. 24 is even, 14 is even, -6, even though it's negative, is even. Okay, B says the number of lines formed by 4 points, no 3 of which are collinear, is what? And I gave y'all 4 points here. So let's just see how many lines I can draw between all 4 points. Let's see, there's 1. There's 2. There's 3. There's 4. There's 5. There's 6. Does anyone see any that I didn't connect? So far, I'm up to 6. Nope, we've exhausted all resources. So how many lines can we make from 4 points? 6. If none of the points are collinear, we can make 6 lines. Okay, C, they ask us to determine what the product of 2 odd numbers is. Again, we've got to test, they tell us odd, but we've got to test positive and negative numbers. So let's see, I'm going to start with 2 easy ones. -1 times -3. That gets you +3. What about 3 times 5? I get you 15. So I've done both negatives, I've done both positives. Now let's do a positive and a negative. So how about 5 times negative 7? That'd be negative 35. So what do all of these have in common? We can't say they're all positive because we have that negative 35. We can say they're all negative. They are all odd numbers, though. So that's what we can say. We can conclude that they have to all be odd if you take the product of 2 odd numbers. Then your answer will be odd. Now, let's say someone wants to give us a conjecture. All we have to do is either prove it or find one single counterexample. Be the devil's advocate on this case and try to find any counterexample to show that it's false. So a counterexample shows a statement is false. Let's look at this next example 3. It says that show each conjecture is false by finding a counterexample. It can be a drawing, a statement, or a number. Just anything to show it's false. A says for any 3 points on a plane, there are 3 different lines that contain 2 of the points. We only have to give one example here of why this could be false. So we only have to find one counterexample to say, okay, it's false. So let's see. It says for any 3 points on a plane. I'm going to draw a plane and see if that's true. Okay, let's see. So I'll put in 3 points. There's 3 different lines that contain 2 of the points. Okay, from this angle, yeah, that's true. 1, 2, 3. Okay, maybe. But those 3 points are all on a different line. Let's see if I put them all on the same line. All in the line. 1, 2, 3. Uh-oh. Houston, we have a problem. Here's my 3 points. How many lines contain those 3 points? Only 1. So if we have 3 collinear points, then we just prove that statement's false. Okay, on to the next one. On the back now. Supplementary angles or adjacent. Well, remember, supplementary means they add to equal 180. So, I mean, if we drew one like this, then yeah, that works. But what about if we drew one like this? Let's say this angle was 27 degrees. And then we came over here and drew something like that and said it was 153. Are those 2 angles adjacent to each other? No. But are they supplementary? Yes. So this example proves the statement is false. So we have 2 non-adjacent angles. Proves that statement false. Okay, the next one says the temperature in Abilene, Texas never exceeded 100 degrees during the spring months. Well, which ones are our spring months? Traditionally, it's March, April, and May. So that statement says we never went over 100 degrees during spring. What disproves that statement? May. May reached 107 degrees. So that shows that statement's false. That's how you show that a conjecture is false. You just have to find one example that makes it false, and then boom, you're done. Okay, let's briefly touch on conditional statements. We'll do more of these in day 2, but let's at least introduce them today. So a conditional statement is a statement that can be written in the form if P, then Q. If you give a mouse a cookie, then he will ask for a glass of milk. That's a conditional statement. So if we put that in symbols, it looks like P with an arrow that and Q. But we read it the same. This arrow right here, you read that as then, the word then. If P, then Q. Then we can even do a Venn diagram of it. The small circle is our P, the big circle is our Q. So what are P and Q? P is what we call our hypothesis. The hypothesis is the part P of a conditional statement following the word if. The conclusion is the part Q of a conditional statement that follows the word then. Now, they won't always be in that order, though. The conclusion does not have to follow the word then, as we're about to see. But usually the hypothesis does follow the word if. So find the word if, and what's after it is your hypothesis. Okay, next example on this topic at least. They want us to identify the hypothesis by underlining it one time and the conclusion by underlining it 2 times. So A, if a butterfly has a curved black line on its hind wing, then it is a viceroy. Find the word if and then circle it. Whatever comes after if is your hypothesis. So this is our hypothesis. Then it is a viceroy. Well, there's then. Then goes with which one? The conclusion. Notice I did not underline the words if and then. They are not part of your hypothesis or conclusion. If and then are not part of your hypothesis or conclusion. Do not try underlining them. That's why I circled them, so we know, oh, they're their own thing. Okay, B, a number is divisible by 3 if it is divisible by 6. First, try to find your if and circle it. There's our if. Whatever comes after the if is your hypothesis. In this case, our hypothesis is at the end. Now, does this sentence have a then? No, but that's because we actually started with our conclusion. We don't need a then. This is our conclusion. Okay, for this last example, they want us to actually write some conditional statements. So write a conditional statement for each of the following. Two angles that are complementary are acute. We want to put this into if-then. So one way is let this be our hypothesis. This be our conclusion. But we need to put this in if-then form. So, if two angles are complementary, then they are both acute. If two angles are complementary, that takes care of our hypothesis. Then they are both acute is our conclusion. Now let's look at this Venn diagram. How do I know which one's my hypothesis and which one's my conclusion? Well, let's see what I set up here. The small circle is our hypothesis. The big circle is our conclusion. So let's label those. Tarantulas is our hypothesis. Conclusion is spider. Now this is where it gets tricky. You can't say if tarantula, then spider. So you can kind of fluff it out and make it a story. So let's say if you are holding a tarantula, then you are holding a spider. Okay, so that's the basics of how we write conditional statements. Like I said, for day 2, we'll get into the nitty-gritty, all the different forms. But for now, I just wanted to touch on it. So this is the end of the notes. Stay tuned for the guided practice.